Good evening, all. Am I audible?
Yes, sir.
Thank you. So, in the previous class, we were discussing about solving Z transform problems on based on properties. Okay. So, we'll continue with those problems. Now, let me share the screen. So, these are the problems which we were discussing yesterday. First two problems we have already completed. That is first one u of minus n, that is time reversal property. Second one time reversal, multiplication by the exponential, then differentiation. So these are the two problems. So order we can change. First it is an un, then the time reversal, then differentiation. Okay. Now we have to consider the next problem, which is x of n is equal to 1 by n minus 2 to the power minus n u of minus n minus 1 u of minus n minus 1. So this is the problem, but what we know is this equation. Okay, so based on this we are going to solve it first. So we know that n into x of n is differentiation minus z into d by dz x of z. Okay, but what about n 1 by n? So to solve this, as I have already explained yesterday, we have to choose another method. Let me multiply this n on this side, n into x of n. This is equal to minus 2 to the power minus n u of minus n minus 1. Okay, now we will find out z transform of this one, then we will equate it to minus z d by dz of x of z. So how to find z transform of this one using properties? We know there is a property minus a n u of minus n minus 1, its z transform is 1 divided by 1 minus a z inverse. One minus a z inverse. Now for us we have minus 2 inside the bracket and minus n here. For this we can modify the property, we can modify our equation so that we can apply the property. Say if at all it is a to the power n u of minus n minus 1, then z transform would be this minus will come on this side, minus 1 divided by 1 minus a z inverse. Similarly, if I have a to the power n u of minus n minus 1, if this is the case, then here earlier this is different, this is different, and this is minus a to the power n is different. Remember that minus of a n is different, minus of a to the power n is different. So we have our equation in this form, correct? Given equation is minus a to the power n u of n minus 1. So already I have explained this. If a is here, you will get 1 minus a z inverse here. If minus a is here, you will get 1 divided by 1 plus a z inverse. Since there is no minus here, we will get a minus here. We will get a minus here. So this is what we are going to get for the given signal. And what about this minus n? In our signal minus n is there. So 2 to the power minus n means I can write it as 2 to the power minus 1 to the power n. So 1 by 2 to the power n, correct? We can write it like this. So now we can write, we know that this is the standard equation. For that, this is the Z transform. If at all our equation is like this, this is the transform. Now for this one minus is there, that will become plus here. Okay, you can observe the change. Here it is minus, here also it is minus. But because of minus a to the power n, we have 1 plus a z inverse. So we can write this implies n into x of n is equal to 1 by 2 to the power n, minus 1 by 2 to the power n u of minus n minus 1. Okay, give me a second. Any problem? So for this one we can write, considering this as x1 of, say x1 of n, let it be, I will consider minus 1 by 2 to the power n u of minus n minus 1. For this, z transform will be minus 1 divided by 1 plus 1 by 2 Z inverse. Okay, this is the Z inverse for this one. But this is equal to what? This is equal to n into xn, not for x of n. So using the differentiating property, using differentiation property, what we can write for this one as n into x of n, z transform of n into x of n is equal to minus z d by dz of x of z. What is the transform of this one? Please, you have to join before 7:05. It will be very difficult for me to assess. So, okay, here. So, Z transform of this one is already calculated here. That is minus 1 divided by 1 plus 1 by 2 Z inverse. So how we can write this? Z inverse will be Z divided by Z plus 1 by 2, minus is here. So this is equal to minus Z, same here, d by dz of x of z. Okay, so now you can see here minus z and minus z will cancel. So we'll get 1 divided by z plus 1 by 2 is equal to d by dz of x of z. But what we want? We want x of z, right? So we want x of z. Therefore, x of z is nothing but integrating on both sides. To get x of z, we have to integrate on both the sides. So after integrating x of z value, you know that integration of this will give us log of x plus 1 by 2. Okay, so here log of z plus 1 by 2. If it is x, then it was okay. So here you can clearly understand, right? Is there any difficulty in solving this problem? First we need to know this equation. This is the standard equation. From this, instead of a to the power n, if we say minus a to the power n, we have a, n means we get a minus over here. Again, instead of plus here, if we have a minus, then this minus becomes plus here. So using this property, we are going to write the x of z. Now after that, z transform of n into x of n we have found out here. Where we were not solving for x of n, we were solving for n into x of n. That means the z transform whatever we have found here, this is equal to minus z d by dz into x of z. So what is x of z? We have to integrate on both the sides to get x of z. So after integration, we get this as our answer. Okay, this is third problem. Fourth one in this list is n into n plus 1 u of n. So this is again a very simple problem. N into n plus 1 u of n. So it might look difficult, but it is a easier problem because we just need to simplify it at the initial stage. X of n is equal to, you multiply n into the brackets, This is n square into u of n plus n into u of n. What is n? Multiplication by ramp. Here ramp square. So this is nothing but differentiating twice. Differentiating 2 times, whereas this one differentiating 1 time. What to differentiate? Z transform of u of n. Okay. So that's why I said it is the simplest problem what we can expect. So this is our n square u of n, n u of n. So let us go through the procedure and solve it. So we have u of n, solution is u of n is there means z transform will be 1 divided by 1 minus z inverse. Okay. Or you can say that is z divided by z minus 1. So this is u of n. Now what is n into u of n? N into u of n, z transform of this is minus z d by dz of x of z. So using this property we can write d by dz of this is our u of n. Okay, u of n z transform idu andre ಈ z transform na ನಾವು differentiate ಮಾಡಬೇಕು. So I will have to keep it like this. This is our correct z transform of n into u of n is this one. So after differentiating, whatever answer we get, it is equal to z transform of n into u of n. Okay, so z transform of n into u of n is that value. So I will not go to the details of differentiation, just I will write the answer here, z divided by z minus 1 whole square. Z divided by z minus 1 whole square is your answer. Okay, now you want also n square u of n, z transform of n square u of n is nothing but minus z into d by dz of z transform of n into u of n. ಸೊ ಒಮ್ಮೆ ನಾವು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಿದ್ವಿ, ಇವಾಗ 2 ಟೈಮ್ಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. z transform of n of u of n ಏನಿತ್ತು, this I will consider as x1 of z. If I consider this as x1 of z, then differentiating x1 of z again will give us n square u of n. n cube ಇದ್ರೆ 3 ಟೈಮು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕು, multiply by minus z every time. Okay, so for this one we can directly substitute. Already we know that the z transform of n into u of n is z divided by z minus 1 square. Okay, so differentiating this, whatever we get as the answer, that is say z into z plus 1, z into z plus 1, z minus 1 whole cube. This is x of z for this value, n square u of n. n u of n is here. So combined x of z is equal to z divided by z minus 1 whole square plus z into z plus 1 divided by z minus 1 cube. Why? Because you can look at the expression here, n square u of n plus n u of n. For this we can calculate x1 of z, x2 of z, or say this as x2, this as x1, because we can calculate this one first and then differentiate that again to get this one. So this is u of n, that's why it is easier to make. If at all it is different u of n minus 1 or something like that, it would have been difficult again. But this is simplest problem with 2 times differentiation. Give me a second. Mr. Sukit, ನಿಮ್ಗೆ ಯಾವಾಗ ಬೇಕೋ ಅವಾಗ ಲಾಗಿನ್ ಆಗೋದಲ್ಲ. You have to log in within 7:5.
Sorry, sir.
So after simplification, we will get this answer. So till here, if you do, then also it is fine. If you have time, you can go for the simplification. Okay. So it is simple, like z, as if you multiply, cross multiply, and then solve, you will get this 2z square, because z minus 1 and z plus 1, we can convert this to, okay, z minus 1 into z minus 1, right? Okay. So we can cross multiply and then simplify. We'll get this, not an issue, but it will take time definitely. Is there any doubt regarding this problem? Let me know if you have any doubt. Yes. N square. Next problem is n square 1 by 3 to the power n u of n minus 2. Next problem is n square 1 by 3 to the power n u of n minus 2. Given x of n is this one. Okay. Problem 18. Though more than 18 problems we have solved, it is according to that question I have put, that is numbering I have put, it is 18th. So x of z we need to find out. Okay. So here you can clearly see 2 times differentiation we have to do. Given signal is 1 by 3 to the power n u of n minus 2. Since we have u of n minus 2, it is a shifted version. So we can apply shifting property. We are solving problems based on the properties, not directly using the equation. So we are solving the problems based on the properties. That's why we need to have apply the shifting properties. For that, n square is differentiating. You leave that n square. It is the differentiating property. What we need to get here also is n minus 2. To get that, what I will do is I will multiply by 1 by 3, and I will multiply 1 by 3 square, and I will multiply by 1 by 3 minus 2. So this will lead us to 1 only, right? So if I do so, this is the given question. For this, using the properties, we need to find out x of z. So first, let us consider x1 of n is equal to 1 by 3 n u of n minus 2. Here n minus 2 is there. Here also what I will put, 1 by 3 to the power n minus 2 u of n minus 2. I have put n to the power minus 2. So 1 by 3 square I will multiply. So this minus 2 and plus 2 will cancel and the result is same. So now 1 by 3 whole square is what? 1 by 9 multiplied by 1 by 3 to the power n minus 2 u of n minus 2. Okay, for this how to solve this problem? How to solve this problem? Anyone can you tell? It is easier now. Shifting property ಅಂತ ಹೇಳಿದೀನಿ. Let we cannot use let, we just use the, we know that a to the power n u of n, its z transform is z divided by z minus a. Okay, or you can write in other way, 1 divided by 1 minus a z inverse. Both are same only. Correct? So similarly this implies 1 by 3 to the power n u of n will give us z divided by z minus 1 by 3. Correct? Now using shifting property, what it says, shifting property states that if you have x of n minus n naught, then your z transform will be multiplied by z to the power minus n naught x of z. Okay, this implies 1 by 3 to the power n minus 2 u of n minus 2, its z transform is z to the power minus 2 into z divided by z minus 1 by 3. That's it. This is the answer for the x1 of n multiplied by 1 by 9. Okay, now similarly this part we have solved. Multiplying it by 1 by 9, 1 by 3 n minus 2 u of n minus 2, z transform will be nothing but z to the power minus 2 multiplied by z is z to the power minus 1 divided by z minus 1 by 3, and this is multiplication factor 1 by 9. Okay, this part is completed. In the above equation, see, we have taken this part and expanded in this form. X1 of z is calculated. Now for this x1 of z, we need to apply 2 times differentiation, because our actual x of n is n square into this value. So we have to apply 2 times since x of n is equal to n square into x1 of n, to get set transform of x1 of z. This is the transform of, sorry, to get the transform of x of z, we need to differentiate x1 of z twice so n into x1 of n z transform is minus z d by dz of z inverse z minus 1 by 3 that is 1 by 9 is also there, that is a constant. Now whatever answer you get, again n square x1 of n is minus z d by dz of this minus z d by dz of z inverse z minus 1 by 3. Okay, after calculating whatever answer you get, you substitute here. I am just reiterating it in the different form, how you can calculate. So first e differentiation find out ಮಾಡಿಬಿಟ್ಟು multiplied by minus z, that answer has to be differentiated and multiplied by minus z. That 1 by 9 I again forgot, right? So 1 by 9 can keep it, or we can multiply it at the end because it is a constant. Okay, so answer for this we have got is, so you can see the similar steps are given in the notes. Okay, so z to the power minus 2, 1 divided by 1 minus 3 z inverse. ಇಲ್ಲಿ ನಾನು ಏನು ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ, z divided by z minus 1 by 3 into z minus 2 ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ, ಅಷ್ಟೇ ಡಿಫರೆನ್ಸ್. ಎರಡು ಒಂದೇ ಆನ್ಸರ್ ಬರುತ್ತೆ, ನೋ ನೀಡ್ ಟು ವರಿ. Okay, you will keep z inverse or z. At the final stage, you try to keep it as z because x of z ಕೇಳಿರೋದು, ನಾವು ಯೂನಿವರ್ಸಲ್ ಇಟ್ಟರೆ ಸರಿಯಾಗಲ್ಲ ಅದಕ್ಕೆ. So finally, after 2 times differentiation, this is the answer. Okay, differentiation part is left for you. Directly I have substituted the answer here, so you can differentiate it, that is u by v rule. So using that you can differentiate and keep the answer. Is there any doubt regarding this? This is a very important problem. You can expect these kind of problems in exams as well. So n ramp ಯಾವ ರೀತಿ ನೆನಪಿಟ್ಕೋಬೇಕು ಅಂದರೆ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಬೈ n ಅಂತ ಇದೆ. ಸೊ we have to use a differentiation. ಸ್ಕ್ವೇರ್ ಇದೆ, differentiation 2 times u of n minus 2 shifting property ಇದೆ. ಸೊ that differentiation ಬಿಟ್ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದು ವೇರಿಯೇಬಲ್ ಇದೆ 1 by 3 to the power n ಅಂತ ಇದೆ. ಸೊ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ಆಲ್ಸೋ n to the power minus 2. ಇದು ಮಾಡಬೇಕು ಅಂದರೆ we have to subtract and add 2. So if we do that, we will get 1 by 3 square and 1 by 3 to the power n minus 2. So 1 by 3 square is 1 by 9. So we can keep it outside and only we will consider 1 by 3 into the power minus 2 u of n minus 2. For this, we will calculate the z transform. After that, we differentiate twice. And in the final answer, we need to multiply by 1 by 9. Or you can keep and everywhere it will propagate. So ಇಲ್ಲಿ include ಮಾಡಿಲ್ಲ actually. ಈ problem ಅಲ್ಲಿ please make that correction. 1 by 9 should be included. Okay, solve ಮಾಡಿಬಿಟ್ಟು ನೋಡಿ. So n square 1 by 3 ಇದು ಮಾತ್ರ ಬರೆದಿದ್ದಾರೆ. So it is 1 by 9 into n square ಅಲ್ವಾ. And these two problems, they are already, this one we have solved. This one u of n plus 2. What is this property? Anyone, can you tell what is the property we have to use for u of n plus 2? U of n is already given. U of n, z transform is 1 divided by 1 minus z inverse z greater than 1. Now z inverse I can write as z divided by z minus 1. Same is written here over here. So u of n plus 2, it is time shifting property, right? It is a time shifting property. So z transform of this is z square into x of z. If at all it is u of n minus 1, it would have been z to the power minus 1 into x of z. Okay, so it is n plus 2, so directly you can write z to z square x of z. It is a very simple problem, so you can solve it, and the answer is z cube divided by z minus 1, and ROC is z greater than 1. U of minus n, time reversal. U of minus n is time reversal. Wherever z is there, you have to write it as z inverse. So you can see here, u of n to z transform z divided by z minus 1, u of minus n andre wherever z is there. So time reversal property, x of minus n is equal to x of 1 by z. So this is the property. So using this property, wherever z is there in this equation, we have substituted as z inverse or 1 by z. And when we simplify, we will get 1 divided by 1 minus z. And ROC is from here itself, z inverse is greater than 1. Because we take z inverse common, then we will get to know that it is greater than 1 or z is less than 1. So reversal ge always I have told, right sided sequence idre z will be greater than 1, left sided sequence idre z will be less than 1. So that is evident here with the equation as well. Now again a similar kind of problem has been asked in the previous year question paper. This is an important problem. You can see this is time reversal, this is multiplication by an exponential, then differentiation. So first an u of n we can calculate. So for this one, this is u of minus n, but here it is alpha power n is there, so we need to make it as minus 1. Okay, so for alpha power n u of n, we have z divided by z minus alpha. If we have alpha power minus n, then multiplied by u of n, it will be z divided by z minus 1 by alpha. So using that, we can write like this. Okay, so let me solve it so that you will understand the concept clearly. So given question is x of n is equal to n into alpha power n u of n. Okay, here u of minus n, sorry. Excuse me, problem with the battery. Let me check the problem once again. So there is a It is a to the power n or minus 1. So here this problem is actually it is a to the power minus n u of minus n. Okay, so n into alpha to the power minus n u of minus n. That's why if we say this as equation, so here also I made a mistake. Sorry for that. Let me consider the problem again. Alpha power minus n u of minus n. This is the problem. Here time reversal property is there. This is not a important. Alpha to the power minus n. Just we know that alpha n u of n is having z transform z divided by z minus alpha. If it is a, z divided by z minus a. So this is the answer. Now if I say alpha to the power minus n u of n, z transform is z divided by z minus 1 by alpha. Okay, this is the answer. Now we have got alpha to the power minus n u of n. Now u of minus 1 you want, that is this is reverse, time reversal. So alpha to the power minus n u of minus n. Applying time reversal property. Time reversal property, what you can do now, we can write, if x of minus n is there, z transform will be x of 1 by z. So for this one, that is alpha power minus n u of minus 1, so z transform is z inverse divided by z inverse minus 1 by alpha. Okay, this is the z inverse of z transform of this alpha power n, alpha power minus n multiplied by u of minus n. Now this signal is multiplied by again n into alpha power minus n u of minus n. This is the actual signal, right? We have found out for only this one. So this would be minus z d by dz of z inverse of 1 minus z inverse minus 1 by alpha. So it is differentiation. Multiplication by n means whatever x of z you have got here, it has to be differentiated with respect to z and then multiplied by minus z. Okay, you can see here. Final answer is this one, alpha inverse z 1 minus alpha inverse z. So go through this problem. N means, this you have to remember, n means minus z into d by dz of x of z. If multiplied by x of n, it is x of z. So similarly, if I say n square means minus z d by dz, then again the resultant is resultant is multiplied by, say, minus that d by dz for n square, 2 times differentiation. Okay. This problem actually I had asked you to solve on your own. Now this problem is a typical problem where convolution is used. I have told you that in time domain convolution is h of n convolution x of n. In frequency domain it is h of z multiplied by x of z. Okay. Some simple problem has been given here. So you can see here h of n is given, x of n is given. We are asked to find out convolution using z transform. Okay. So h of n, x of n, y of n is convolution x of n with h of n. Correct alva? So using z transform andre y of z we have to find out, that is x of z multiplied by h of z. So x of n ಗೂ z transform find out ಮಾಡಬೇಕು, h of n ಗೂ z transform find out ಮಾಡಬೇಕು. ಅದೆರಡು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರೆ y of z ಬರುತ್ತೆ. Now you have to apply inverse z transform, then you will get y of n. So this is the procedure. So first you have to do, you have to calculate x of z, then you have to calculate h of z, multiply both to get y of z, then apply inverse z transform for y of n, and that is your convolution, that is y output using z transform for the convolution operation given. Okay, let me solve this. H of n is equal to 1 by 2 to the power n from 0 to 2. We want x of n convolution h of n given, that we know that x of n is something that we will write h of n is 1 by 2 to the power n for zero to 2. Okay, and it is 0 elsewhere. Delta n minus 1, 4 delta n minus 2. X of n is delta n plus delta n minus 2 plus 4 into delta n minus 3. n minus 1. And n minus 2. Okay, this is our problem. Now what is 1 by 2 to the power n? For this z transform we have to find out, and for this also we have to find out the z transform. So first let us find out x of z. X of z is n is equal to minus infinity to plus infinity x of n z power minus n. But here delta functions are there. Already we know that this will result in 1, that is, let me write it completely, minus infinity plus infinity delta of n plus delta of n minus 1 plus 4 delta of n minus 2 multiplied by z to the power minus n. Okay, this function exists only when n is equal to 0. This function exists n is equal to 1. This function exists at n is equal to 2. So if we substitute that at n is equal to 0, 1 into, that is delta of 0 z to the power minus 0 plus delta of, again 1 if I substitute, delta of 0 z to the power minus 1 plus 4 delta of 0 z to the power minus 2. So what we get as z transform is 1 plus z inverse plus 4 to the power 4 into z to the power minus 2. This is our x of z. Okay. Similarly, h of z is equal to summation n is equal to minus infinity to plus infinity h of n z to the power minus n. So limit is what? Limit of h of n, it is here 0 to 2. So let me write that n is equal to 0 to 2, 1 by 2 to the power n z power minus n. This is the value. So now I have to substitute n is equal to 0, 1 and 2 only. So 1 by 2 to the power 0 z power 0 plus 1 by 2 to the power 1 z power 1 plus 1 by 2 to the power 2 z power 2. So this is the answer. So 1 by 2 to the power 0 is 1. Then plus 1 by 2 z plus 1 by 4 z square. 1 by 2 square is 1 by 4. So this is our h of z. Okay. Now y of z output is nothing but multiplication of z transform of x of z and h of z. So because of this we'll get 1 plus z inverse plus 4z to the power minus 2 multiplied by 1 plus 1 by 2 z plus 1 by 4 z square as our answer. Okay, now we have to multiply each and every term, and the answer we get over here is this one. Okay, final step, let me explain here itself. Y of z is there. Now y of n is, y of n means inverse z transform of y of z. Okay, inverse z transform, if I take 1 means it is delta n. 3 by 2 z inverse means plus 3 by 2 delta n minus 1. 19 by 4 z inverse square means plus 19 by 4 delta n minus 2 plus 9 by 4 delta n minus 3 plus delta n minus 4. So this is the answer. Z power n is a minus 1 is andre delta n minus 1. Z power minus 2 is andre delta n minus 2. If plus 2 plus 1 delta of n plus 1 n plus 2 are iti barute answer. So it is the simplest. Now it is like introductory to inverse Z transform as well. Okay, based on the standard delta functions. Okay, find the value of x of 0. This is for homework, as I have said. X of 0 is initial value. You can solve it. Again, similar problem. One by n minus 2 to the power minus n. So this kind of problem we have already solved. Using properties. And then this P24, this is an important problem. Do solve this problem. Okay. And next class onwards we will start with our inverse Z transform. Okay, another 3 to 4 classes I will complete that. If you have any doubt, you can ask, or else we'll go for the next process, that is your attendance.